Properties of exponents. Now suppose we were asked to solve the question 8 to the third power divided by 4 squared. Well, how do you solve it? To solve this question, we can use properties of exponents. There are 4 properties of exponents, and they are the product of powers property, the power of products property, a power of a power property, and the quotient of powers property. Now, these are not all the properties, but these are the 4 main properties you'll be using and the 4 main properties that we'll be discussing. Now, the first property that we are going to discuss is the product of powers property. And that property basically says if you have a variable, a, and an exponent, m, and then you're multiplying it, and then the same base, and then a different exponent, n, then basically you can keep the base and then add the 2 exponents. So it's equivalent to a to the m plus n. And now let's do an example. So suppose we had 5 to the 3 times 5 to the 7. To solve this, we can use this property. So we keep the base, and then we can add the 2 exponents. So that is equal to 5 to the 10. Now, suppose we had 3 to the 3 times 4 to the 5. Now, we cannot solve this question using this property because they have different bases and different exponents. This property only works if they have the same base and different exponents. Now, the next property that we are going to discuss is the power of products property. And that property basically says if you have a to the nth power, and then you're multiplying it by a number b to the nth power, so they have the same exponent and different base, and you're multiplying it, then you can basically multiply the variables a, b, and then keep the exponent, so it's equivalent to ab to the n. Now, suppose we had 5 to the 3 times 7 to the 3. So we basically switch some of the variables in the first one. So now, to solve this question, we can multiply the 2 exponents, or bases. So that would be 35, and then to the third power, because you keep the exponent, so it's equivalent to 35 to the third power. Now the next property is the power of a power property. So basically that property says that if you have a base, a, and then to the m power, and you have parentheses, and then you're multiplying it by an exponent, n. Well, to solve this, we have a, and then we can multiply the 2 exponents, m times n. So if you have one base and then an exponent, and then you're multiplying it by an exponent, then you can just keep the base and multiply the exponents. So if we had 3 to the 5 times 7, then we can just keep the 3 and then multiply 5 and 7. So it's equal to 3 to the 35th power. Now this power only works if you have one base and you're multiplying 2 different exponents. Now the next property that we're going to talk about is the quotient of powers property. So that property basically says if you have a base, a, and then to the mth power, and then you're dividing it by a to the nth power, then you can basically keep the base and then subtract the 2 exponents. Now you may notice that in the first property that we were talking about earlier, we had this a to the m, and then we had a to the n, but we were multiplying them. And when we multiplied them, we added them. So when we divide them, we subtract them. So they're kind of alike. Now suppose we had 5 to the 7 and divided by 5 to the 3. Then we can basically do 5, and then the exponent would be 5 minus 3, which is equal to 5 to the 4. Now I want to remind you that if you have a division symbol, then that is equivalent to a fraction. So if you have 5 to the 7 divided by 5 to the 3, it will be equal to this fraction right here. So you can always replace the division symbol with the fraction symbol. Now let's do another question. So we have 16 squared times 4 to the 4th power. Now for this question, you have to use multiple properties, because the first thing you think about is multiplying them, but you can't just multiply them because they have different bases and different exponents. Now, however, we both know that 16 is equal to 4 squared. So maybe we could replace 16 with 4 squared and then to the 2nd power. Now, in an earlier property we said that if you have a base and then 2 exponents that you're multiplying, you can just keep the base and multiply the exponents, which is equal to 4 to the 4. So this question is basically 4 to the 4 times 4 to the 4. Now to do this, we can keep the base and then add the 4's. So it's equal to 4 to the 8th power. Now let's return to our previous question that we were talking about before, which was 8 cubed divided by 4 squared. Now, as we know, we cannot use one property to solve it, and that we have to use multiple. But we know that 8 and 4 can both be simplified, or not simplified, but you can write it as an equivalent. You can write it as an equivalent exponent with a 2 as the base and then different exponents. So, for example, 8, you can write 8 as 2 cubed, and then 4 would be 2 squared. So it's basically that, and then we also have the cubed and then the squared. Now, as we know that if you have a base and then 2 exponents, then you can basically keep the base and multiply the exponents. So the numerator is equivalent to 2 to the 9th power divided by 2 to the 4th power. Now, as we know, if you have division and you have the same base and different exponent, then you can just keep the base and subtract the exponents. So it's equal to 2 to the 9 minus 4, which is equal to 2 to the 5th power. So basically, 8 cubed divided by 4 squared is equivalent to 2 to the 5th power. Now that is all for today's video. Thank you. Additional practice links will be placed in the description box below. And if you like, subscribe, and share this video, I would really appreciate it.